Lesson 39A, the inverse of a 3 by 3 matrix. In the next lesson, 39B, we'll actually use the inverse of a 3 by 3 matrix to solve three equations in three unknowns. So first of all, let's find out how we work out the inverse of this matrix given as indicated. Now, first of all, what we have to do is set up another matrix, which is a much larger one. It's fairly complicated business, this, but okay. All right, here it is here, a big one. And what we do, we look along here, number 3, if we cross out that row and that column, we're left with this little determinant. And we put that little determinant in here. That's called a cofactor. -2, 4, and -2, 6. Okay. Then we go along to this one. Right. We cross out that row and that column, and we get this little cofactor here, which is the 3, 5, and the 4, 6. And then we go ahead over here, and we cross out this row and this column, and we're left with this little 2 by 2 here, which is 3, 5, -2, -2. Now I'll just pause this and finish these off. Okay, now I've finished those all off. Now just checking one of these ones down here, right? This one is here, so we'd cross out that row and that column. We get the 2, the -1, and the -2, 6. This middle one here, right? Well, you'd go here and you'd cross out this column and this row, and you get the 3, the -1, the 5, and the 6, and so on. Now then, what you do is you alternate the signs in each of these little cofactors, and we've got here, this will be a plus here, plus there, that's a minus, a plus, a minus, a plus, a minus, a plus, a minus, and a plus. And then you work out each of these little determinants, not forgetting to changing the sign. Now, you can pause the video and give that one a go and see if you get the same as what I got. Okay, did you get that? Now the next step is to write down this diagonal, -4, 23, and -12, and then swap these guys across the diagonal. So the 2 goes down here, the -10 goes to there, the 6 goes up here, and the 4 goes down there, and the -15 goes here, and the 16 goes there. Okay, next what we do is we work out the determinant of the original matrix. You can do that, and so we work out now over here. We'll call this A. And so we work out the determinant of A, and if you work all that out, you get the result of just -12. Now the inverse matrix, A inverse, is simply equal to 1 over the determinant of A minus 1/12 times this new matrix. Now, what you need to do though is just to verify that is the case, is to check, and the way we do that, we simply say that if A times -A gives us the identity matrix, and the identity matrix in this case is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1. So identity matrix. So if I multiply the A, now that will be equal to the 3, 3, 5, minus 2, sorry, positive 2, minus 2, minus 2, minus 1, 4, 6, times this one, minus 4, minus 10, 6, 2, 23, minus 15, 4, 16, minus 12. Now we could have multiplied each of these by minus a 12th, or we could do it just in there. And that should give us our identity matrix. Now what I'll do, I'll set this up in an Excel spreadsheet, and you can see that in fact that will work. That if you multiply this one times this one, then multiply by minus a 12th, you'll get the 1, and so on. Alright, now here's a little Excel spreadsheet. There's our original matrix here. Right, and I've worked out each of these little cofactors. There's a -4 coming in. If I just click on that, on there you'll see that's your B2. There's your B2 times a C3 minus a B3 times the C2, giving you that one, and so on. So I'll just click on each of these so you can see each code. You can come back and check these later. There's the code for that one. There's the code for that one. 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 And code for that one. Right, that's the hardest part of the whole operation. So you can set it up as an Excel spreadsheet yourself. Now here, the determinant of A. Right, there it is there. Just check that code, just working out a determinant. But you've already got that as another Excel spreadsheet and another lesson. Here I've just changed the sign. So we change that minus changed to a plus. And here comes the transpose, which you've just flipped these across the other side. Right, so I've just taken that one there as your E8, which is over here. And then we divided through by each of these by the determinant of A, which was this one here, giving it this one. Right, now, just as a check, to show it does work, so you can verify your new matrix when you pop it in. There we go, there we go, there we go. So I've multiplied each of these. That row times that gave you the 1, and that row times this column gave you the 0, and so on. So there's your little 3 by 3 matrix to inverse to calculate. Lesson 39b, simultaneous equations, example 8. Solve using the inverse matrix, 3x plus 2y minus z equals 0, 3x minus 2y plus 4z equals 3, and 5x minus 2y plus 6z equals 3. First of all, I'll write down this matrix, just taking the coefficients in front of the x, y, and z. So we'll have this matrix 3, 3, 5, 2, minus 2, minus 2, minus 1, 4, and 6. Now this was the same matrix we had in the first section 39a, so we'll call that A. Now the inverse of this we worked out in that section to be minus 1/12 of, and let's get this right now, that's minus 4, 2, 4, minus 10, 23, 16, 6, and minus 15, and minus 12. Right. Now, having worked that out, this is how you set it out. You say that this 3, 3, 5, 2, minus 2, minus 2, minus 1, 4, 6, that is A, multiplied by x, y, z is equal to 0, 3, 3. Now if you look at that row by that column will give you this line, which is equal to 0. And this row by this column is this line, which equals 3. And finally, this row by this column multiplied together will give you this line, which equals 3. So we've set up the equations in a matrix form. Now, the next step is to say that x, y, z must equal, now we'll call this one, remember, A. There'll be A, the inverse of A, times 0, 3, 3. Bit of matrix theory I've skipped there, but you can see the logic of it. Now we've already worked out what the inverse is. There is up there. So that will be equal to minus 1/12 of, I'll write in here again, minus 4, 2, 4, minus 10, 23, 16, 6, minus 15, minus 12, multiplied by the 0.33. Now rather than multiplying each of these cells by minus a 12th, I'll do this multiplication first. And when we do that, we get that we're multiplying this row by that column, we get minus 12. And multiplying this row by that column, we get 24. And multiplying this row by that column, we get positive 12. So we can see that x, y, z is equal to, this will be 1, this will be minus 2, and this will be minus 1. And you could actually leave it in that form, or we write x equals 1, y equals minus 2, and z equals minus 1. Alright, now we'll have a look at the Excel spreadsheet again, just to see how it works with that one. Alright, now here's the Excel spreadsheet. Now as you can see, there's the augmented matrix all set up. Okay, so that's the A section there. So augmented, there's the numbers on the side. Now this is as before. We worked out the cofactors here. Right, we've done this before. Then we worked out the determinant of the original matrix A. Okay, then we changed the sign, and then we swapped them around. Now we swapped them around, and then we've divided each one of those by the determinant, getting the inverse matrix. There's the inverse matrix there. So all we really had to do to work out what x, y, and z were is to get that 1. What I've done here, you can see I've multiplied E11, right, by D1, then F11 by D2, and G11 by D3, and that gave us the value of 1. And the same thing with the other one, is this row multiplied by that column, and that row multiplied by that column to get the final result. And you can set up this matrix so you can solve this way rather than the determinant method. You can use the inverse method. Some of your calculators have got the inverses on them, so you just work out the inverse and apply this very, very simple rule to work out the 3 equations and 3 unknowns.